Get your day started right. From our shack to yours, this is Coffee and Ham Radios. We are live in 5, 4, 3, 2, 1.
Good morning, everybody. How are y'all doing today?
Did something happen?
I so wanted to remove Jim from the stream right as it started. Like, Jim, where the hell are you? What's going on?
What button did you push?
There he goes. Somebody is playing in the background.
Hey, everybody. Welcome to the stream. This is Coffee and Ham Radios. This is Jim's first time doing this. We're having a little bit of fun with him right now.
Rookie.
I so wanted to just mess with him even harder, though. I was going to be like, where's Jim? Where's Jim?
Oh, Lord.
Hey, there he is.
Okay.
Are we up and working now or what?
Yeah, we are. Y'all were having me on, and I might have had a technical malfunction here. All right. Good morning,
Jim,
guys.
You need a break, like, change your underwear, come back.
I might need oxygen and my heart pill, because, good Lord. Okay.
Yeah, there's something happened there. I don't know what it was. I was hearing the show like 2 or 3 times.
Yes, that was a technical glitch on my side as well, and I have remedied that.
This is Jim's first time hosting everybody, so we have to cut him a little bit of slack.
I apologize for the terrible production values this morning.
It's happened. It's happened to all of us, so I wouldn't worry about it too much.
Woo. Okay. Well, for what I'm making off this, I'm not too worried about it. Oh Lord. How are y'all doing this morning?
Before we get too far into it, TC Fitz sent, and I think it was also Plasma, sent in a coffee yesterday. Let me double check that. But we were having so much fun yesterday with Kevin. So many questions flying by that we didn't get a chance to even talk about it. No. Plasma Storm and TC Fitz both sent in some coffee pledges. You can support the show and help Jim gain some confidence by clicking the link in the description down below, or any of the other ways. Even the super chat button works. So thank you very much, folks.
I was afraid Abe was going to yell at me. He's like, Jim, I told you, don't click the red button. So how are you guys doing this morning? We're having a great day. Everybody got coffee?
What's so fun?
I just went and got some more. I went high test this time.
See, Abe's prepared.
Yeah, he's got the.
It's not going to run out today.
So my kid is not here this weekend, and Mrs. Perry will not go get me another cup of coffee. The kid still listens to me. The wife is like, nope, not happening, Captain. So I prepared in front. We have a great show lined up today. You guys ready for this?
I'm ready.
Yeah, I don't even remember what we're talking about, but I'm excited.
It's ham or ham adjacent things, right?
Yeah, exactly.
Great. So we are going to talk about Bandpass filters today, awesome. And what they're for and why you'd use one. And Ape and Chuck have got one made, and they're going to show us those, and we'll take a look at that. So,
T-Ray. Yes, sir.
Bandpass filters.
Thank you, T-Ray.
Oh, thank you, T-Ray.
What are Bandpass filters?
Well, I think what we're saying when we talk about bandpass filters and why they're important is they will reject frequencies on other bands, right? So it gets, you got it all right there. Look at that.
I've been trying. I've been up since 5 o'clock working on this, man. So, yes. So go ahead. I'm not going to read the slide. You're doing fine.
Well, so the thing is like when you think about the spectrum of RF frequency, it goes from very low to very high, right? And then you have like low bands, like you have your 80 meter band, you have your 40 meter, 60, 40, 30, 20, 17, 15. What can happen to your radios? So
70.
When we made the transition to solid state radios from tube radios and all that kind of stuff, solid state radios can pick up intermodulation, third order intercept artifacts from broadcasts of other radios, especially if they're close to you. They'll come through your receiver, through your front end, and cause noise and cause havoc. So what we want to do is we want to put a filter on our transmission line somewhere between the radio and the antenna that will attenuate frequencies on bands that we're not operating on. Now, what a lot of people make mistake about is they're like, well, I got a 20-meter bandpass filter. I'm good. Go ahead and operate on 20. If you have two stations that are close by operating in the same band, you're still going to have a problem. So when you have situations like contesting where everybody's out at field day, or when you and your buddies pack up in the minivan and drive out for POTA, you have to make sure that you have bandpass filters for the different bands and that you're operating on other bands, or you might have a problem with your radio.
The harmonics are what get you, right?
Yeah.
So 20 and 10 are 20 and 15 are harmonics of 40. Well, I guess 10 is too.
Correct.
So as Ape was saying, those harmonics, even if you're down on 10 meters, you're like, well, that's a long way from 40. Well, it's one of the harmonics of 40. So it's the thing that makes the DX Commander work like it does with just a 40-meter wire gets you 15 and 10.
Thank you, Liberty, for the 762.
Thank you, Liberty
Sorry
Cave.
to interrupt you.
Liberty Cave, you're awesome. Appreciate it. So, and the bandpass filters are used in a whole lot of different applications. And I don't want to read the whole slide, and Ape covered a lot of this, but they're in other things besides just amateur radio use. In all sorts of technology, anything that uses waveforms, electromagnetic waveforms, like sonar, seismology, medical applications like EEGs and electrocardiograms. They're used in optics because those are electromagnetic waves too. So, they're all over the place. You want to use one on field day when you and your buddy are set up at your awesome spot and have the kegerator out and are grilling the brats, and you're both trying to outdo each other on field day, and he's blasting your doors off. He's on 40.
Brats, by the way, not brats. Brats.
I said brats. I said brats.
I know you said it wrong.
Oh, damn.
It's bratwurst, not bratwurst. Unless you're grilling your children, those are brats.
There's a couple times I've grilled. Anyway, so
look at Joe Brett's like, get back to talking about radio,
man. Joe Brett, you see what I'm dealing with here. So go ahead.
Yeah,
Go ahead, please.
It's gonna be a fun show.
Yeah, Gordon was saying something about it being a harmonic modulator. So let's think about it like this. If I use my radio and I make a transmission on 7.15, right? So that's in the 40-meter band, 7 megahertz frequency. Mm-hmm. Because of the way the frequencies work, I'm also going to have a emission on 14.3, which is in the 20-meter band. Right? Now, we use filtering in our radios to minimize that secondary harmonic to a certain level. Radios also generate spurious emissions on non-harmonically related frequencies, but we're not worried about that right now. So that becomes a little bit of an issue. But your radio will have trouble filtering just signals in general, and they usually refer to that as intermodulation, and that's a much, much more complex topic. So it's not just harmonics. It's something called artifacts of harmonics, which is a third order intercept. But I don't want to get into all that. But basically, it's noise generated by people broadcasting within your region or area that can cause overload or front end interference on your radio. The use of bandpass filters drastically reduces that. Also, back in the old days, before everybody was on cable and streaming TV and all that other stuff, people used to use low-pass filters or even bandpass filters in their house. So, like when I would transmit, say, on, 6 meters or something like that, I could be causing problems on people's television sets in higher up UHF and VHF frequencies. So I would put a filter on that would attenuate those signals as they came out of my radio. So it's all filters are used differently, but it's all for the same thing. It's for the allowing frequencies through a gate and blocking the other ones that you don't want. And then bandpass filters are just specifically tuned for a certain set of frequencies.
So following up what Ape just said, this is exactly what a bandpass filter is going to look like. It's made of a low-pass filter and a high-pass filter together. So we are allowing frequencies to go through here, and we're blocking stuff on either side.
Yep.
We have our band of interest that we're allowing. And then these can also, and this is going to vary by application. So you can also have a wide a wide bandpass filter and a narrower bandwidth bandpass filter. It just is going to depend on what application you're doing with it. So what we have is, and I want to show a couple examples of some, and then we're going to jump into apes. Awesome video here.
Well, without a bandpass filter, what we might have is a failure to communicate.
That's right. So these are just a couple of examples I had. These are commercial bandpass filters. I got these off of eBay. And bandpass filters have kind of a wide price range. These were probably $30 or $40 for indeterminate age filter. So this one is probably air band based on what it's passing, and this is what it's excluding. And its specs are showing that it's going to knock off 60 dB of attenuation.
Nice.
Outside of the pass band.
So I don't know if you guys watch The Green Donkey at all, but he goes to this place called Mount Diablo in California, and he uses 2-meter radios to make these super duper long contacts. And he's got a video where he's got this giant Yagi antenna. He calls it the Saggy Yagi.
The Saggy Yagi.
I like that.
It's awesome, but he feeds the transmission line through that to. It looks like a damn scuba tank, like this giant scuba tank, and then which is basically just a giant bandpass filter, or they call it. There's something else that they call it besides a filter, and then it comes out and it goes into his radio, which he operates the squelch completely wide open. But he does that, so he is only getting 2-meter frequencies. There's one right there.
I have to interview him, I think, maybe.
My God, that guy, he
might not be safe for work, but it would be awesome.
He is a clever person.
A clever cleaver.
Yeah, I think cans to him.
Yeah. I talk to him all the time.
So here's some other bandpass filters, and I just pulled this up off of DX Engineering.
Oh,
I have that. These are commercial ones.
Yeah.
These are all rated at 200 watts. These right here. When you're looking at the giant 200 on the side. When you're looking at the filter, what you're looking for is what band is it rated for? Look at Chuck flexing. Look at him flexing.
That's right.
So you're looking at what band it's rated for, and you're also looking for obviously whatever the power rating is that you're going to use in your application. And they have several different kinds. Go ahead.
I have to say that when I bought this, I thought it was for something totally different. I thought it was for noise. So
I got nothing on that one.
I know. I was like a year in. Come on now. I'd already built like 6 antennas by that time.
That's 6 bandpass filters in one. That's pretty awesome.
Yes.
Oh, look at that.
Now this puppy is rated, I think, for 200 watts. Yeah,
it is. Jim, can you buy that and do a video on it? I want to see what's inside of it.
That's what I'm talking about.
Yeah, right after the channel pays for it, I'll totally buy it. So that guy's kind of the big dog. And I this was not an extensive look. Now this one's a little more affordable at $700, and this is rated for 100 watts.
It's automatic too. How does it know?
It's half the price.
It's got to sense. It's probably a sensor.
Yeah.
Sensing.
Yeah. And that runs. This guy runs off of 12 volts.
There it is.
So,
it's got a serial port.
Yeah. Yeah.
So the radio tells it what band it's on, and it automatically switches itself over. Okay.
That's right. Get you. There's only three in stock. You better hurry up and order that.
No, that's their brand, right?
Yeah.
Yeah. These guys make a lot of stuff.
That's their house brand.
Almost as much as MFJ.
We're not sponsored by them yet. I mean, at all.
Not yet. So we've been talking for the last 3 weeks, and we did a project. Ape and Chuck have built some bandpass filters, and so we're going to jump in here and listen to the professor introduce us to the project that we took on for this. Are you ready for that, Ape? Or were you going to say something?
Ready for this?
No, I thought you were going to say something, so I didn't want to.
Okay,
nothing
of
value.
What I did is I searched the internet high and low to find some documentation about building your own bandpass filters, and what we found was this document from the ARRL.org. It's by a gentleman by the name of Lou Gordon, K4VX, and I believe this was for QST Magazine, and I believe our friend Lou has done multiple articles for them. But here we have bandpass filters for HF transceivers. Do your multiple transmitter field day or contest efforts suffer from interstation interference? These handy and inexpensive filters can help. It's exactly what we're looking for. But today, in addition to field day and contesting, what we see are groups of buddies will go out to parks on the air. They'll go to a park and want to do parks on the air. And they could be causing interference to each other, what he's calling here interstation interference. Depending upon the proximity of the antennas and the amount of power that they're using, they could just be wreaking havoc. So that's why today hams are looking for these things. They can be expensive, so a lot of hams are looking to do their own, and that's what we're looking at here. There will be a link to this below, so you can read all of it in its totality, but we're not going to do that right now. A couple things I do want to point out is that here you can see they're looking to do a 100-watt version. So that's what we're looking to do here. We're looking to build one of these for 100 watts.
Because we're the barefoot guys.
And they go through the filter design and construction. Here is a basic schematic. It is a 3-pole Butterworth bandpass filter. As you learn more and more about bandpass filters and components and things like that, some folks will build a 5-pole Butterworth because they think it has steeper drop-off and more stability at the top. But this is the product that we're going to build here. And then you can see it's a simple in and out. You have two components here. You have a capacitor and an inductor. In parallel, then you have an inductor and a capacitor in series, and then you have a capacitor and inductor in parallel again. Down here is a table that we are going to pay some attention to. The first column is the band, and so for this project we are going to do 14 megahertz because we want to do 20 meter band. The second column is capacitor 1 and capacitor 3 have a value of 500 picofarads. Capacitor 2 has a value of 50. Inductors, we use the letter L to show for inductors. Inductors 1 and 3 are going to have 0.28 microhenries, and inductor 2 will have 2.8 microhenries. So for this project, it may be a good idea for you to go ahead and have a capacitance or an inductance meter, often called an LC meter or an LCR meter. Here you'll see when we go over the parts, T68-6 cores and T80-6 cores are what is recommended. And they talk about the number of turns of your enameled magnet wire on your core. For inductors 1 and 3 and 2, and then here for the 80, it changes with size. And then your filter, your frequency in megahertz here at the end. Now here they talk a lot about on the right-hand side different toroidal cores and different things that you can use. And the gist of what I remember here is that here, if you use T80-6 cores, you can use larger wire for these inductors, and winding the inductors start with the number of turns specified in Table 1. We're actually going to use T94 cores for availability in my parts box reasons, and we should be fine. But again, larger cores, larger wire typically will help you with higher wattage, and again, we want to be somewhere around 100 watts. So bigger is better. Down here, they talk a little bit about the capacitors. Silver mica, again, is something that is typically recommended. You can use polystyrene capacitors, which are very difficult to find. As a matter of fact, I had some trouble finding silver mica capacitors, so I'm trying to stock up on those. And then he also talks somewhere around using 20% tolerance disceramic capacitors. I wouldn't do that. But you want your capacitors to be rated at 500 volts or higher. He goes over tuning the filters. We'll tune these as we do a build. Here is the actual physical parts layout, and you'll see that as we build out the box. And then actually this is the PCB board pattern that we want when we go ahead and we etch our board. Now we're going to do a physical or manual etching. We're not going to be using
Thank you, Steve.
any of the acid that they use to do that. It's not going to be an acid etch board. And I really think that is going to cover what we want to. You can read this, like I said, article in its totality via the link below. All right, let's move on.
Hey, share Colin's thing there real quick, because that was some good info he put there. Did you see that?
That is great info. Yeah. Morning, Chuck.
So what Colin was saying
Colin.
is that you don't need to, if you're using an amp, you don't need to build a filter for 1,500 watts. You can build it for 100 watts and put it between the radio and the amp.
Yeah.
And that is in the document that we just had up there, the PDF.
Yeah.
Lou talks about, originally he was building a 1,500 one, and he says all these parts were starting to cost a lot of money, so he decided to put it in between. So it's a
Nice.
good point.
Yeah. That's an awesome way to do it. So when you were building this, now you mentioned it, parts is parts, so you decided to go on the toroids you had available.
Actually, I didn't. So my full build video that releases today, we'll explain that. So when I was looking at it, so in the article, he says you can use these T68, which means 0.68 of an inch in the outer diameter. He says, but you could also use bigger ones, these 0.80s, for higher power, right? To make it just a little bit more robust. I didn't have these. These are T80s mix 6. It's a powdered iron mix 6. I only had 94s, which is a little bit bigger. So I was going to use these 94s, but then the 6s showed up the day over the course of 3 days. The 6s showed up in the mail. I also have these 6s in mix 2, this red one, but which is probably fine. But I didn't use it. I used the yellow ones. So
6s. I thought that 6 was the mix.
I'm sorry. This is mix 6. These are mixed. The red is mix 2. And so
even they makes a mistake on the story.
Steve Payne did a video about a year ago on Bandpass filter that he did a fantastic job.
Video.
Yeah,
and he used mix 2, not mix 6.
Okay.
Now let's take a look at this. What are the gray ones?
They're ferrite. So when you look at this,
different. Okay.
And when you look at these ferrites, they're a mix of iron. They still have iron in them, but they'll have manganese, or they'll have zinc, or they'll have other elements in them. So this is a ferrite core, is how it would be classified. The other ones are classified as powdered iron cores.
Okay. So what I did is I played with the toroids I had, which are 140s.
Roids.
Yeah.
And
let's take a look at that real quick. Take a look at that real
quickly. How we measure these. And again, as I said, these are 140s, and that's going to be an outside diameter.
See, I got a caliper. This is science.
Of the toroid in inches. Ooh. And that's showing
my toroid's bigger than apes.
Inches with, a wee little bit left over.
Wee little bit, laddie.
Size toroids.
Wee laddie.
Again, the article is talking about using a T60 or a T80. That's not what I have in hand. So these are the ones we're going to use. We're going to use our LCR meter after we wrap our toroids to test for the value. Now I'm going to give this some test wraps for the purposes of showing you guys this. But the article for 20 meters, for example, for a bandpass filter for 20 meters is looking for 0.28 microhenries on the L1 and L2 toroid, the L1 and L2 inductor, and it's looking for 2.8 microhenries on the L3 inductor. Now, obviously, this is overkill for this bandpass filter, but that's what I have, so we're going to work with that. All right, I'm going to set that aside. I'm going to set that aside. I'm going to set that aside, and we're going to get to wrapping.
So now, if I was TO, I would stop and say perfect 3 or 4 times in this, but yeah. So I just... this is a way different toroid than is in the article, so I gave this some test wraps so we could see where we are. And I want to show you guys this and the wrap, and then let's measure it.
I've got some wraps on this toroid, and for our demonstration, this is going to be plenty. What you want to do when you're working on a toroid and you're trying to figure out how many wraps you need,
happy
and
pencil.
I think we've talked about this before on the channel.
Happy pencil.
And in Coffee and Ham Radio, every time the wire passes through the toroid, that's a turn. Not any of this on the outside. Nonsense. Every one of those is a turn.
Perfect.
So the article that we were talking about today with a T80, and again, this is a 140, is talking about 7 turns and 25 turns. Well, so we're just going to fake it on this one. So I have 1, 2, 3, 4, 5, 6, 7, 8 turns through the middle of this guy.
8 turns.
Those are 8 turns that go through the middle. So now that
someone had too much coffee this morning.
This was all we were going to do.
I'm having a blast.
We want to spread this out, and we want to make sure our wires are
like
as tightly
32
wrapped.
gauge wire.
around the toroid
It's
as possible
It's pretty.
It's tiny.
to enhance the magnetic field and create a better inductor. And I've heard that you're supposed to spread these out, so we can certainly do that. All right, so there's our wrap, and now I'm going to set up the meter, and we'll see where we are with the Henrys, with our inductance values.
It's all about the Henrys.
All right, so you can see we have 11.3 microhenries here. That's actually much higher than the values we're looking for this project. So if I was going to use this toroid specifically on our project, what I'm going to do is I'm going to change the number of wraps. So quickly, I'm going to disconnect this from our meter, and I'm going to unwrap one or two of these.
Dang it.
That bothered Chuck.
And let's see where we are.
Well, no, I forgot to check mine.
And you can see
I forgot I had a meter.
that a few wraps, that was just two turns that I took off, dropped us down to 7.4. So as I undo more, of course that inductance value will change for every turn I pull out. And of course the inductance value on this is also dependent on the size of the inductor. And for this project, this inductor is way too big.
And the mix.
I wanted to show you guys how you're going to do the wraps and what you're looking for when you're doing the wraps. So you would obviously check the values you're getting on your meter with what is specified in the documentation if you're following someone else's plans or what you figured out by doing the math.
Hey, I shared a diagram if you want to pull it up real quick. WEC was asking about it.
Great.
It's the same diagram as the one from the article. It's just it's just drawn differently. This was a modeling tool. This is a modeling tool called Elsie that I put it in. So like you can see. Let me actually go put my mouse on the actual thing and see if you can see it. I swear I don't know what I'm doing around here. Anyhow, if you take a look at this, you see there's a 50 input, 50 ohm input, and a 50 ohm output. So depending upon the actual impedance of your antenna system, these things can behave differently. But it's called a third order intercept Butterworth filter, and I think we might talk about that later on because third order Butterworth filter.
Yes, third order.
Because it has three different components or three different circuits in it. Circuits 1 and 3 are what they do is they shunt to ground frequencies that you don't want, and they do that based off of the resonance of this frequency here that's made with this inductor and with this capacitor. So the squiggly line's an inductor, your wrap toroid, and the equal sign, for lack of a better word, is your capacitor, and the different values are here. Order 2 passes the signals that you want through onto the next circuit, which will filter out, again, shunt out anything you don't want. I think that covers it, WEC.
And that's a T network, right? Or is that a pi? That's a T.
I have no idea what it is, to be honest with you.
It's a pi, 1 over and 2 down, because it looks like a pi symbol. Strong gang signs on stream.
Okay. Sure.
So a pi network is 1 over and 2 down, and then an L network is 1 over 1 down. It looks like an L. So we're not terribly fancy at naming things.
But that's the schematic for it.
And now he's got his mouse working. Yay.
Yeah, so here's your 50 ohm input, your 50 ohm output, your AC. This is your AC power source to ground, and you can see this is the shunt where these things in parallel go straight from your center conductor right to your ground. These are your parallel components. So,
and that's hold on, don't get rid of it. And those are the values that we were looking for when you wrap that toroid. Is the 280 nanohenries or 2.8 microhenries. So that's going to be 0.28 microhenries there, but yeah. So very cool.
So while we're on this topic, Bill Munghaven asked a question. He says, "Are there any recommendations for LCR meters?"
Here's the one I use, and I dropped a link for this in the chat.
Okay, that's the one I have too.
Yeah, it's like $50, and this is just an LC. It doesn't do LCR, so inductance, capacitance, and R would be resistance. This just does inductance and capacitance. Use a regular multimeter for resistance.
You should give us a lesson on how to calibrate it while we're looking at it.
I can do that.
Next show.
So while you're getting set up for that, yeah, we can do it now. Leprechaun Introduction Academy is asking, what would you use this filter for? What is its application? So on field day, you've got a whole bunch of people that are all in the same location that are all using a bunch of radios and they're all trying to make contacts. And if you've got your friend over on 80 meters, and I say friend, and if you've got yourself on 40 meters and you have another friend over on 20 meters, the person on 20 meters is transmitting close enough to you that it's going to just blast the front end of your radio. So you'll use a bandpass filter to pass the band that you're interested in into your radio and filter out all the other bands that you're not interested in. So your 40 meter signal will come in, the 80 meter signal from your friend will not, and the 20 meter signal from your other friend will come through. So that's what it's going to do. It's going to allow the band to pass into your radio that you're interested in.
Close enough. All right. This is Ape's meter. Now I have a different one, and I can find it on Amazon and share the link. I'll be glad to. There's a whole range of these things out there, and mine is about $40, $45. It is not high end.
So when you use these, you can use the zero as your calibration, or your zero out button. Thank you, Skeeter. Awesome. This is high C and low C. I'm sorry, high C and high L. When you test inductance, you can do it at different frequencies. I believe this one does it somewhere around 500 hertz and then 5,000 hertz. I don't know exactly. I always just use the lower LC. It works fine. And I can use this to switch between inductance and capacitance. So say I'm going to be doing capacitance. Right now I'm getting a capacitance reading, but I don't have anything hooked up. So I just want to hit this zero button. And I've zeroed it out. And now I can take my capacitor and I can just go ahead and put it in. And we get somewhere around 500 picofarads. It's a little high. These are within 5% tolerance for it. Notice that when I zeroed it out, I had these things disconnected. If I was on an inductance measurement and I want to zero this out, I have to have them connected in order to do that. So I would connect them first, and it's already zeroed out. But then I would just do this, and it's zeroed out. That's how you calibrate it, Chuck.
Okay, that's what I did.
And this is one of those things where you'll wind up with a series of tools. You'll have a regular multimeter, you'll have an LC meter, you'll have like 6 or 7 different meters, and you'll wind up running out of bench space. So,
right, yeah. And I would tell you when you buy a meter, you know, I would either recommend the one Ape has, which he's been using for what, 2 or 3 years, 4 years. I don't know. You've had that thing forever.
And it does, Don.
It works well, and you know. All right, so let's take a look at Ape's build. And my StreamYard keeps freezing up.
I think it's the next video is the next vignette is parts. I think it's just where I talk about all the parts.
Yeah, that's the one I was going to try and add, except it's
that we are going to need to do this particular project.
And we'll
start
ahead and
by
fix
talking
that. I
about
can't.
This Hammond box. Now, they recommended a size for this. I think it was the 1590N, and this is like 1590N1, I believe. So I couldn't find the exact one, but this is close, and it should get us there. It's just an aluminum box that we're going to use to house our bandpass filter. It does come with some screws that you use to mount that there, and it also came with some rubber feet that I probably will not use, but that's okay. These are sold in 3-packs. And I'll have a link below. Now, on either side of this box, we're going to need to put an input and an output for our signal. And we're going to use these SO230. Can you turn it up to you? That I have.
I can see.
If you buy these, what I would say is that make sure that you're getting 50 ohm connectors, or bulkhead connectors, I think is what these are called. You don't want to accidentally buy 75. And we'll mount them similarly to what we did on the RF tap project that we did a couple of weeks ago. And so that will be that. Now, in terms of the innards, according to the instructions, what they recommend is you buy some of this copper-lined PCB board. And we'll have to manipulate this for a couple of reasons. One is we're going to have to isolate some mount points, but also we're going to have to cut. And I cut this with a pair of shears. This to fit into the bottom.
That's why it looks so janky.
Like so. Now, when we do this, we're going to have to somehow fasten this. Some folks will drill holes and then put some mounting hardware in there. And we're not going to do that because the mounting hardware will cause something less than flat on the bottom of this. So what we're going to do is use some of our favorite stuff, Gorilla double-sided tape, and we'll just put that down underneath, and we should be fine with that.
That seems legitimate.
Now, when you read the instructions, there are a couple of different things there. These yellow toroids are mix 6. These are mix 2 powdered iron toroidal cores.
Thanks, Lionel.
Thank you.
As we call them. This is a 68 is the size for this, and let me see if I can find. All right, I tried to use my calipers to measure these so we could have an educational session here, but the batteries are dead, so I'm just going to go ahead and put
Jim got us covered earlier, though. So we're good.
yeah, but, I believe these are T68s, and this is means that they're 0.68 of an inch in diameter for the outer diameter. What is said in the article, I believe, is that these are a little bit smaller. You have to use a little bit thinner magnet wire when you wind these, and they struggle a little bit at 100 watts, which is the goal of this project. We want a 100-watt bandpass filter. So it says to use a T80, and that's what this is. So this would be 0.8 of an inch in diameter on the outer diameter. And you can see it's a little bit bigger, but unfortunately, I do not have the Type 6 mix. I only have the Type 2 mix. I probably could use this, and I probably would be just fine. These in Type 2 cost about $2, $2.50 a piece. But we're going to use these. They're a little bit bigger. So these are Type 6 mix, and I believe these are T94s. They might be 97s, 96s, something like that. But they're close to an inch across, so they're a little bit bigger, much bigger than the 60s. You can see that right here. And so this will help us in our quest to use 100 watts. Not that big of a deal. What they recommended is a 20-gauge magnet wire. So that's what we have here from BN Tech Go, and really like this company. I use a lot of their wire for a lot of different projects. There'll be links to all this stuff in the bottom, so you can pick it up if you want. And then the final thing that we need are some capacitors. And what I like to use, and what is recommended, is these silver mica capacitors. They're supposed to be a little bit better, have a little bit better tolerance, and last a little longer than things like these ceramic capacitors. Now, I'm not an expert on capacitors, but if you are, I'd love to hear all about it down in the comment section below. We are going to use these silver mica capacitors, which are more expensive. These are about $2.50 a piece. These are practically free. But again, we want to build a quality product that will stand the test of time, stand up to use, and work well for us. So what we needed is a 50 picofarad and 2 500s, and that's what we have right here. All right, let's get to building.
All right, so what was your total parts cost for exactly what you need to build? Because you bought probably that's extra.
Yeah, like I put these dust caps and stuff on here, and that all that stuff raises the price of it up. You could probably put one of these together for about $40 to $45, depending. Now, part of that, so like the case is like $7, $8. So and then each one of these toroids is about $2.50 to $3, right? So that would be $9. Okay. So you're looking at 15. When you buy the clad board, you have to buy a 5-pack or a 10-pack or something like that. But the board's probably about $1 in there. Capacitors, say $2.50 a piece, is another $7. It's probably actually even less than $40. It's probably more like $30 to $35.
About 75 cents a board per board.
Yeah, it's not. Then your connectors. These connectors are probably $3 a piece. The thing is that when you're done with this, it's significantly less than buying the $130 one. Yeah. The hard part is getting these to work correctly. So it's not an easy build by any stretch of the imagination.
Well, I mean, it didn't look like a hard build to physically put together. You're saying more on the tweaking side is where.
Yes. So when you think about it, there's a lot of magic in the sauce. Or you have 3 different tune circuits working in harmony together, right? And so getting each one of those tuned 100% accurately and working together. And then like you see when you put these in this box, when you get near toroids and stuff like that, you introduce reactants. And so when you put them all in this box, and like I have these two might be too close together. There's just stuff everything in like Hassler's law, everything affects everything. They're difficult to get just right. But WC's totally right about using the quality ingredients.
Yeah. So let's take a Chuck's got his build video, so let's take a look at it and see we can judge Chuck now.
I just did that. All right. Well, Ape and Jim wrote me into doing one of these Bandpass filters with them. This is a piece of copper that is bonded to a PCB board. Okay. That's the original size. Now, I've cut one for the box. I'll show you the box in a second. This is the one I cut. So let me move that one out of the way. Sorry, it's kind of hard to see because of the glare, but now I've marked this out because what we're going to do is I'm going to take out these sections that are in around the square. And that separates this from this. And I will do that outside probably because it's probably going to make a mess. I'm going to try and use a Dremel. So I've got a Dremel here.
There is no try. There's only Chuck or not Chuck.
It's hard to see, but that's a diamond blade. I think it's on the edges. It's on the edges and the top there. So I'm going to try and use that, see how it works. I got to make a mess. So I'm not going to do it in my shack here. And then this is the box that we're going to put them in. I'll turn it sideways. That helps a little bit. And it's just a metal box. And it's fairly small. I couldn't remember the name of it. Now I need to put SO239 in each end. And then this will drop inside here. And your toroids and your capacitors will all solder to that board. So let me see if I can route this thing out and then make it look halfway presentable. Okay, guys, so I took that out. It took me probably less than 5 minutes to do this. There you go. There's a good angle right there. Not perfect, but pretty close. I used the blue tape just to kind of give me a guide, so I didn't go crazy. Because I've done stuff before in carpentry where I was supposed to cut one part and cut the wrong part. But so that's just a guide. So there's that. So now what I need is holes in here. And what I'm going to do is I'm going to cross. Let me just do it for you. Let's see, I had the tool here a minute ago. Oh, there it is. Let me throw my eyes on. So I'm going to try and find the center of this just by doing the old across the corners here. So I'll do across this corner. I'll just put a little line somewhere in the middle.
That's not a little line.
It's
like a 1/3 line.
He's got that big old iron angle thing there.
That's a
it's pretty close.
It's like we're building a house.
Right, let me get my right angle out here, boy.
And I will check I don't have these yet, unfortunately. I've got something I can drill a hole. So I'll just show you this again here. Let's just do this real quick.
Thanks, Chuck. I missed it the first time.
Corner to corner. I know. I don't know why I put it twice. I'll take it out later. Draw a little line. Corner to corner. This is for that guy that always asks, how did you do that? How'd you find the center? And draw a line. So this is where my hole will go for my SO239s.
My daddy taught me that trick when we were installing
this
ceiling
is something
fans.
else I'll draw outside and show you later. I'll probably do a pilot hole, and then I'll do a step bit.
When you're a carpenter, if you pull your tape too many times, the boss doesn't like it.
I think this is thin enough for my step bit, so it should work fine. Okay. All right,
he's really rough with his
holes. Rough. Came out pretty nice. Like I said, I used a step bit. If you don't know what a step bit is, this is a step bit. I will leave links to some step bits and probably all the products that I have here. And also, this is the little case or set that I bought for my Dremel, and it's pretty nice. It's got a bunch of different things in there. I'll link that in there too. All right, so pretty close until I get my SO239. That's about where that's going to go, and then this will go in here like this. Yeah, there we go. Hard to see because of my lights being shiny. But I'm going to build this outside. I'm going to build it out here someplace with all the stuff. And then do like Ape did. He did double sticky tape on the back. the gorilla, the ape strength stuff, and put that in there, and then put that in after I get done, and maybe after I test it too. All right. Like I said, I'll put everything down in the description for you guys if you need any of these parts.
Awesome. So I saw a couple of good questions come up. The leprechaun, I forgot. Leprechaun.
Introduction.
Leprechaun. That's it. Was asking, so, and Ape, this is for you to explain because you're good at this. He was asking, to the size of the lifesavers and all the rest of the hardware out there, what determines the frequency of our bandpass filter? And I think we kind of talked about this already, but
yeah. So the size does play of the toroid can play a factor. The bigger ones, you definitely get more wattage through, and same thing with heavier gauge wire. If you need to go bigger and bigger, like from a power standpoint, you want to use bigger components. But the frequency is determined based off of the characteristics of the circuit, which is the amount of capacitance and the amount of inductance that you have in each of your components. So that's why you want to use a good capacitor that has a high voltage rating, and you want to make sure that you use a meter to measure through your capacitor, make sure it's right. But you also want to use a meter to measure the inductance on your toroid. So whether you have a bigger toroid like this or a smaller one like this, you can get these both at the 0.28 microhenries, depending upon the number of wraps that you're using. So It's really just the values of the components that determine the frequency.
And for example, when I was showing mine, I was using a 140, which is a lot bigger than Ape's. And, with 6 wraps, I still had like 7.4 microhenries. So the size of the toroid and the amount of wraps interact a lot with each other. Chuck, hold yours
through this.
Chuck, hold your filter up. You had it up a second ago. I'm gonna.
Oh. So there's the finished. Well, not finished. I only have the one capacitor so far. The other I'm still waiting on the other one.
Yours is still a work in progress.
But I learned from Ape said it was really hard to build it in the box, and that's why I built mine outside the box.
I was going to say the edges of your board are very clean looking too, and not raggledy-paggledy.
You know what expensive tool I use for that, Jim?
What?
Dremel?
The Dremel? Oh, the X-Acto knife.
I just scored it a bunch of times and then just broke it.
So now I've got a question for you guys. Oh,
here's some others. This is a 130, so this is at 1.3 inches, and this is a 200, which is 2 inches. So maybe one day I'll do a video on the toroid box. Everybody can see all the toroids in there.
And there's different mixes. So, and Ape's got this memorized. I have to Google this every time or ask Ape. But so like there's the powdered iron mix, which are the colored ones, the painted ones. Is that a true statement?
It is.
Then that color is the mix. Correct?
It's supposed to be, but you never know what they do in China.
Okay.
All right. Tim, I was just really careful, and I just barely. That little diamond blade I was using, the rotor blade, it cut it really easy, and I just laid it on there real light, just light enough to keep it from bouncing.
Just steady hand.
He looks older, but that hand is the hand of iron.
I drank 6 cups of coffee just before I did it, so
there you go, right?
And honestly, Tim, it doesn't matter if you cut through the board as long as you don't cut all the way through and it disappears, because you're trying to isolate the copper from the rest of the board. So you want to get all the way through, and if you make a hole,
and
who cares? It's fine.
Yeah,
and it's pretty even. You just got to get the copper off.
So the next question I had for you guys was, you use the Gorilla Tape on the bottom of yours. So why would you not want to do standoffs and tie the ground plane of your device to the?
It was I don't know, pain in the ass probably. I used the Gorilla Tape to put it in there,
okay,
and then
science.
But here you can see I tied the shield connector with these red wires.
Oh yeah, okay, yeah.
And that's and those 2 spots that are left over are the one over here and the one up there. Oops, those are for grounds.
For your grounds.
It is grounded to the box.
So you could fasten that to the box if you wanted. You don't have to use the capacitive directance of Ape tape.
Yeah, if you look in the article that Ape showed earlier, that guy screwed his to the bottom. He just screwed it to the bottom. Looks like.
Right. Yeah, and I'm with Abe. You'd have stuff sticking out the bottom of the box that'd look a little.
Yeah, well, he did that, and he also used ground straps from the.
Yeah, he did both.
Yeah.
Okay. So now on the box you use, that's an aluminum. As Hayden would say, that's an aluminium box, right?
I think it's die cast.
It's supposed to be aluminum, but it's probably got a little bit of lead in there. It's, again, I'm not making fun of China, but I'm talking about China. I mean, it's probably got lead and everything else in this box.
It drills really super easy. It's when you drill it, it comes. It doesn't look like metal bits when it comes out. It looks like ceramic almost when you drill it. It's really weird. I'm going to use this stuff since I have just a little roll of this stuff that I bought a long time ago. It's just grounding strap.
It's called braid, right?
Braid, yeah, ground braid.
Pre-tinned. So you could also use an aluminum. Well, like those ones from DX Engineering, those were like in a much thinner sheet metal style case.
They are.
Right.
So would the case affect the characteristics of that filter some?
So when you look at the case that they're using Gigaparts, there's holes in the side of that case. Now, you remember when we built the RF tap, like we used a Hammond box case like that because what we want to do is we want to minimize RF interference to these components. I don't know how the Perfo box avoids that, but they're also a different. I believe that's a Chebyshev. I think is how you say that filter. I don't believe it's a Butterworth. I could be mistaken. I only briefly saw it. So
I could take this apart.
Scott had a video recently that showed the innards, but he didn't really zoom in on them. And I believe that's also a fifth order
ham radio for non-techies
design.
So now when you talk about orders, and I think you mentioned this earlier. So the more orders excellent. When you design the filter, the more orders you add, is that increasing the capability of the filter to get rid of those unwanted frequencies?
So it's my understanding. So it'll help with that. It's my understanding that the more orders that you have, the steeper your shoulders or skirts are, and then the more stability that you get at the top. I have a picture of some Bandpass stuff. If you like, I drew.
Nice skirts.
If you want to take a look at it.
Okay. Did you
soft skirts?
I can share. Give me 1 second.
Yeah. This is.
Oh, there you go. That's perfect.
Yeah, this is one of those filters I showed. This is that airband one, and I've got a video where I shot it live, but this is just as good without me talking as much. And this shows you a pretty steep side, like Ape's talking about on this guy, and a fairly wide band on it as well.
Well, yeah, that airband filter should be wide, right? Because you're trying to get a lot of spectrum. When you're looking at something like the 20-meter band, you only want it to be, 500 kilohertz wide, or
right.
But like something like this has got to be multiple megabyte or megahertz wide. But your skirts there are very, very steep, which means that you're going to have good attenuation on closely adjacent signals. So that's a good looking bandpass filter.
Yeah, so we're getting really technical with some terminology like skirts and so on. So real quick, on this slide that we've got shown here, you see the left-hand scale is -70, and there's a little bit of squiggly nonsense there. Your radio won't be able to hear a signal very well that's -70, 70 dB below the noise floor. And then you can see it rise up, and then you see the number 1 and the number 2 at the top of the screen. He's got the markers at the bottom. So number 1 is 110.4 megahertz, and then all the way to the other side is 141.4 megahertz. That's what's allowed into your radio, and then that skirt drops it right off the edge. We're back down to -70. So you're only hearing between 110 and 141 with this filter that he's got right here.
And this is what we're talking about, our pass band. So literally this is built from a high pass filter and a low pass filter together. You could, not on this particular one, but you could cut out part of the circuit and you wouldn't have a band pass anymore. You just have a high pass or a low pass.
Right. So the high pass is the lower side where he's got marker 1. Everything above that is allowed in. The low pass is where marker 2 is. Everything below that is allowed in.
Right.
And so that becomes a band pass filter. So you're passing the band into your radio. That's where all these technical terms come from. So this picture makes it real nice.
The swoop is the skirt. So
swoop.
leprechaun.
Swoop.
And then at the top of the skirt, that's typically referred to as the shoulder. And you consider the bandwidth where you have -3 dB. So once the signal is attenuated -3 dB, that's considered the roll-off or the cutoff angle of your filter.
Right. And I should have moved the markers down and done that, but it was late. And I was.
Nobody's judging.
I'm judging me. I'm judging
Here you go,
me.
Jim.
Let me embiggen Chuck here.
So this one was built. This is the top of it. Okay, so this is the top. It sits like that in there. But
this is your DX engineering filter, right?
yeah, or what their name is?
And that white
Lord,
stuff is
it's-
actually quality. You want that white stuff. We'll get into that when Chuck's done.
Yeah, actually, Don brought that up earlier. But if you look, everything is like hung from the top, and like this is the bottom of mine, but there's the top. This is the bottom of this one, so it'll sit like that. But it's a little different setup. I don't know if you guys. A pretty good picture there.
1, 2, 3, 4. Yep.
So that's like
5. That's 5.
Yeah.
I don't know which one this is, but it's if you look at and
6.
this is what I'm going to have to do is if you look at these capacitors where they're put together to get the right
Yeah, that's a 6th order.
PF, I guess.
Yeah, but that's some serious components there too. That's
This
a
one
quality.
looks really complicated.
Now there's see if you look at those toroids, they're yellow and blue. Some of them,
Right.
and they're different colors. So here's where my paranoia comes in, and I say that's how they get you. They might just be painting that blue on there so you can't copy that, right? So you have no idea what the values of those components are, and you can't make it for $80 and undercut them. The other thing is that there are multiple different colors of toroids, and they might be using different ones for different
I
things.
have some of these blue yellow ones, and real small ones like that.
So the thing is that when you make these, Jim talked about it earlier when he said the Q factor. So Q factor is the amount of bandwidth that you're messing with in your filter. A 6 and a 2 have different Q values at the same picofarad value. They'll have different Qs because of the composition of the toroids. So there's all kinds of science that goes into toroid selection and why you would pick one and why you would use one. And a lot of times for hobbyists, it comes down to cost. Right? To say, I'll do it cheap because I'm a ham and I'm supposed to do things cheaply.
That's not what you were going to say.
Red asked a question. He says, you say bandpass filters are used most for field day, no notch filters, etc. So your radio has a bandpass filter in it. And when you click from 20 to 40 to 80, a lot of times you'll hear a relay going off, and that is you switching, something's directing across your different bandpass filters in your radio, whether they're made like these toroids or they're made with micro components. So you have them there. What this does is an extra layer of filtering that you put in your transmission line because you're going to have frequencies being used within proximity. If you don't have frequencies being used within proximity, you don't need it, right? So that's one of the reasons that you would use that. Now, where people get confused, and it's easy, right? This is a complex thing. Your band pass is the entire set of frequencies for a particular band. So 20 meter band pass is 14 megahertz to 14.350, 35 kilohertz of spectrum. In your radio, you have something called a pass band filter. This is band pass. Your radio has pass band filter. Your pass band filter is roughly 3 kilohertz, much, much smaller, right? And that is what is coming through your mixer, and it's being filtered out to the point where you can hear that or see it as a spike on your display. That is your pass band filter. So the band pass is how much band comes in, and then the pass band is the percentage of the band that you're looking at. Super confusing topic. Now, of that 3 kilohertz signal, you might have somebody tuning up, or you might have a birdie, or you might have some kind of interference, and then you need to use a notch filter to get rid of that.
That's where I was going.
Right, so you can have a notch filter on your pass band filter on top of your band pass filter. All of those are mixes of high cut and low cut, or high pass and low pass filters. So when you really look at I don't know if audio change is the right word or not, but when you really look at everything from electromagnetic wave in the sky to coming across on the earphones, there's a shitload of filters. I mean, there's just, right. And so what this is just adding another filter in that chain to improve our signal.
Where does this stop band fall in there?
So use a stop band just like you do a Bandpass filter, and you would use that typically on your transmission line to stop. Like, so I have a stop band filter I did a video on for FM broadcast because I have an FM station close to the house that sometimes can cause problems when I'm using my SDR. So I just keep that filter in my transmission line, same way I would do as a band. Think of it as an anti-bandpass filter. So instead of allowing the band, it completely stops it.
And like Abe said, there is the curve for a stop band is exactly the opposite of that picture I showed earlier. Now, Abe, did you have a slide? You said something about a slide when I popped.
I do. So, but I think yours covered it. But we can talk about it real quick.
Yeah. Before we get too far away from this, that white goo that was on all of those toroids. When you assemble a toroid, and Greg mentioned this and Don mentioned this in the chat, the number of turns, the spacing of the turns, the mix of the toroid, all of that stuff goes in to make up what the Henry's reading of it actually is. And once you get that tuned in and dialed in, you get that white stuff, that hot glue on there. It's all it is hot glue. And that stops it from moving. So I've got it all tuned in. And now when I toss it in my go bag and run down to the field, it hasn't changed from the time that it was sitting on my bench. So that's why all that white goo is there.
Yeah, if you bonk those windings around on that toroid, it will absolutely change the value of the toroid, and then that'll change the whole value of your filter.
Doubt. So this is just quickly. These are your skirts, right? These blue lines right here of your. This is an S21, and I have a video called S parameters and NOVNA if you really want to get nerdy. But this is your skirt and this is your shoulder here, and where this green line is your 3B is your roll off or your cutoff frequency. So your effective filter that's passing through is everything above this green line represented in blue. And then here's just another filter. So what you do on the lower end, so this is our frequency across the bottom, FL is your lower frequency of the bandpass, FH is your higher frequency. So what you do is you say FH minus FL, I know that's math with letters, gives you your bandwidth and tells you how wide your bandpass filter is or how much frequency would be able to come through. And when you build a filter, what you want nice steep skirts like this. At the top, you want this touching zero, so that means you have zero insertion loss. So when you put things in your transmission line, it attenuates everything. You want your filter not to attenuate inside your pass band, inside your band pass. That's what they should look like. Now we'll see later what mine looks like, and it ain't quite like this, but
that's beautiful, man. It's beautiful. So I saw a couple other questions. Liberty Cave was asking why low bandpass filters don't we want to filter high bands out too? Or is the third order harmonics issue a one-way street?
No, it's a combination of both.
Exactly, Leprechaun.
It's both in there.
Right, and that's what we were showing with what Abe just showed was basically a low pass and a high pass together. Correct. And that graphic I showed at the beginning, it's the same thing. It just depends on what you want to filter. We're talking mostly about band pass today in the context of field day, right, which is coming up in, a month or so. And like I said at the beginning, when you're transmitting on 40, you have harmonics that are spewing out on other bands as well. And your neighbors are not going to appreciate that when they're trying to get their 12 field day contacts as well. I'm an underachiever on field. So.
12, that's like my record for the last 3 years combined.
Right? That's what I'm saying. That's right.
We tend to eat and drink more than we field day.
I was boasting a little bit.
Barbecue.
So yeah, that's
So also, I want to get on Red's question there too. Most people that go on a soda, they go by themselves, or maybe one or two people, so it's not a big deal. But when we've done some of our YouTube ones, it's the total opposite because there's like 5 or 6 of us, and usually only 3 or 4 radios.
Thanks,
but
Don.
If he remembers. At Yosemite, I was having problems with that because I set up kind of close to the other guys. We had this like kind of a small area, and even when I think Christian had set up quite a ways away from us, and he was just like blowing my radio out. And I think I got a feeling that the QRP radios, because that's what I was using, I don't think they have I don't think the rejection on those is quite as good as like a full 100-watt radio, and especially if you got 100 watts near you. So this is something that, you know, for those type of trips, and I'll bring mine if I for Arizona there.
Yeah, anytime you're going to have
it works.
multiple operators in close proximity, you'd absolutely want
right.
a bandpass filter like this. So, Ape mentioned
I don't know if that's
this,
what it's asking or not, but I just want to say that.
Ape mentioned this earlier. Do you remember the website for that? Have you got a link for that, Ape?
Yeah, I do, and I'll post it in the chat.
There's a program. This is how you can figure out a lot of this, and there's a ton of online resources. If you Google bandpass filters, you will be assaulted by thousands of articles on how-tos and online calculators, as in tell us what frequency you're trying to pass. And
yeah, so RF filtering
and,
isn't limited to ham radio, right? So like every electronic component in your house has them. So when you look for filtering videos to learn from, you're going to get a lot of guys talking about some complicated stuff. It's a lot to wade through. You want to find specifically topics for ham radio to put it into context for what you're doing, not if you're trying to build it like an RF transmitter for microwave or something like that.
Right.
And they go immediately to math. Like so many of them are just pure math.
Yeah, and the math for actually figuring this out is fairly complex.
Yeah.
Do you have an example
go the other way
of that?
around?
I don't have any math examples.
Okay. Yeah, I had one and I meant to save it and I didn't. But like I said, there's the LC program and there's a ton of online calculators and websites that explain this. That ARRL article that Ape talked about in one of the vignettes is great on point with how to do this. And it's a great article, and it's like, 40 years old almost. And that piece of the hobby hasn't really changed in 40 years or longer.
Liberty's asking if there is an alternative to LC for Linux users.
Probably.
So, Liberty, this is a website, rftools.com. I believe you can use that.
Yeah.
You can do that to mess with filters. I don't know if it gives you the same functionality that you get with LC, but it's a good place to launch the canoe.
DC.
Right. Yeah, there are just tons of online sites to help you figure this out. So, do we see any other good questions in the chat? I mean, we may have about wound this clock out.
It's a lot. It's a complex topic, right? And so I know a lot of times hams will try to tackle it in a 15-minute video.
Rob was asking about circuit boards.
Let's see.
The circuit board's just a way of mounting it, Rob. I think I understand what he's asking. And they mounted everything kind of in off. If you looked, I just put all the 20 screws back in it, but it was mounted to the ceiling on little boards, like some kind of a board to like isolate it, and then everything was tied together down below.
This looks like the plastic zip tie anchors that you stick on the wall.
It did have. You're right. That's what it was.
But again, I can always go back to Kastler's law. Everything affects everything, and so I'm sure that the circuit board has something some monkey business there.
And your hand touching it is going to have some monkey business as well.
Yeah.
Well, when I tested it with my spectrum analyzer, with the lid on and with the lid off, I got different readings.
Mm-hmm.
Do you have any? Did you save any pictures from your testing?
I did.
Did you want to share?
I don't mind sharing.
Okay.
Let me just get it pulled up here. Share screen, share window. And so it's not the happiest story. I just being honest. So this is my response curve, and when you take a look at this, you can see the roll off the three. Actually, you know what? That's not the one I want to share. Hold on, give me 1 second.
You mean you have one that's more embarrassing?
No, I have one that has more data on it.
My brother's working on it, man. I'm going to cut him some slack.
This is the one.
T.O. is harsh.
He is.
Oh, no, can you believe him? Can you share? There you go.
Real. That's what we do, man.
Keeping it real.
So when you take a look at this, I have markers at 1 and 2 which if you come down here, you can see the amount of attenuation is 3.15, 3.12. So you want to be at 3 dB of attenuation. On the higher side of this frequency here, that skirt is not bad, but it's not deep. It only goes to -20, and I really want that to be at least -40 dB. So that's a problem right there. The other one is that between my 2 points, I want this to be flat, and it's not. So that's a problem right there. But if you look down here at my frequencies, that's 11 to 13.8. You're looking at 3 megahertz. I definitely don't need it to be 3 megahertz wide. So this one should be over here, which would then give me lower insertion loss. But then the skirt on the lower end of the spectrum is not as good as the skirt on the higher end. So there's a problem there. So I've got 3 things that I need. One, I got to tighten this up. I got to drop this down, and then I have to make this look more like a skirt than a shoulder. So there's 3 things that I need to continue to work on my filter.
Now, and that's showing that's between 11 and 13 megahertz. So
that's not the right. It's not 20 meter band.
you passing the wrong band, bro.
Right.
Okay.
Right. So there's some stuff there that needs to be tweaked.
Well, I mean, it's like one hand on the filter and then run the test and see what.
Yeah, what I think I'm going to do is I think I'm just going to build another one and then have the 2 to compare and see what happens. It's a fun project. I mean, it was definitely an awesome thing to work on, and it was definitely a cool learning experience.
Right.
So I really did enjoy doing that.
I wasn't, when you guys first started talking about this, and I really did mean kind of roped in when I said that, but I think I've learned quite a bit about the filters themselves and about how to read the schematics and stuff for building stuff. So that was good.
Right.
Well, that's why we do these things, right? We want to learn because we want to learn, right? And then we also want to bring everybody along for the ride. And so what we do with these videos, if folks haven't noticed, one of the approaches we like to take is all of us do a little bit of a snapshot of a project that we're working on, mash them together in these Coffee and Ham radios, and then we'll each release our own full builds on our channels. And it's just a good way to just make sure that community-wise we all learn. That's how we all learn together and from each other.
Now, and a lot of people don't have these big scopes like you and Jim. Now, can you do this on a Nano VNA?
You can do it on a Nano VNA, and I didn't do it on a Nano VNA because Jim is constantly giving me grief over not using my spectrum analyzer.
Well, that is what Jim does. I've got a tiny SA.
I actually knew the answer to that. I just wanted to hear.
Jim is always giving him grief about it because the brother's always like, I put this on my Nano VNA. I'm like, you got a beautiful spectrum analyzer that's technically better than mine. So
so I do a lot of the stuff on the Nano VNA to show that, hey, you can do this with a $75 piece of equipment, not a $1,500 piece of equipment.
He's not all about ham gatekeeping.
Well, I'm gatekeeping. I'm gatekeeping.
No. Ape is trying to be inclusive instead of gatekeeping.
Yes, that's right.
So what I'm going to do is I'm going to take that list of these parts that we've been talking about today. I'm going to order some myself, and I'm going to build them up. And if anybody wants to order along with me, let me know over in Toad's Discord.
Okay, sounds good. And Rob, hey Skeeter, thanks for the
Skeeter. Thank you, man.
Skeeter, that's twice, Rob, man. Thank you.
Yeah,
Rob brings up a good point. I like it done this way. We see different ways of doing it, and that's just like our antenna build, the Artemis. I built it totally different than Ape built it. And
then I built it the way Ape told me to build it, and that was totally different. Thanks, Ape.
Yeah, no worries.
So,
and then I took pliers to the magnet wire and screwed the pooch on that one.
We weren't going to talk about that.
Oh, I will. I own it, man.
Okay.
I own it.
All right.
Awesome.
So,
Bill, if you check out my channel, I had a video. I think my last video, maybe it was 2 back, was testing a single one of these circuits, then use that as a trap in your antenna. I did a video testing that with a Nano VNA. The same technique is what you would use to test this.
I think we're going to do a live stream with me and Ape testing mine.
Yeah, we can do that.
Do it. Yeah.
Chuck on a Nano VNA. That'll be great.
Well, my buddy Ape just sent me one, so.
That's right.
Thanks, Greg. That's high praise coming from Greg. Thank
Chuck,
you, Greg.
we are going to... Yeah, Greg, thank you very much. I appreciate it. Yeah, Chuck, we're going to drag you into 2022. We are totally.
I'm going to kick all the way, baby.
Yeah, I know, Pop. It'll be okay. Well, guys, I think that's about a wrap. That's a wrap. I think we had a good
Any
Works
other
for me.
questions? Maybe, I don't know. We probably question.
I mean, if we got any other questions out there, now is the time. The professor is still here in the room.
Does he have a YouTube channel? Hiram Percy Maxim is long past, my friend.
Well, Steve, what are you up to coming up in this week? What have you got going on?
Yeah, so we've got a show to put together for tomorrow night on SDR control. That's the hot new hotness in ham radio is controlling the ICOM Trio from a Mac or Apple product. So fantastic stuff. We're going to play around with that live tomorrow. I have it. I've used it once or twice. Jim has it. He's been using it nonstop for like 2 weeks since he got it. Yeah. And his boss hasn't caught him yet. Because you can ham radio remotely. You can do voice remotely. You can do digital modes remotely. You can just change like settings in your radio remotely if you wanted to. I don't know why that would be any fun, but I want to make some contacts. So that's what we'll be doing tomorrow night on Ham Nuggets. And then over to you, Ape.
So what I just did is my full build video will drop in 15 minutes. It is not a premiere, so I'm not going to be in a live chat scenario because I have stuff.
Gotta go cook a steak.
I got stuff I need to do. I think we're going to go for a short hike, but I'm trying to convince everybody to stay home and cook on the grill. But we'll see what happens. And that's it. That's
awesome.
Chuck, what do you got going on?
Hey, well, I got a video coming out sometime this week. I have to contact the maker, but I was sent one of those. It's a company called Reolink, and they do security cameras. They asked me to do a video on it, and actually, tell you the truth, I didn't know whether I could actually set it up or not, but it worked. Well, I don't want to spoil it, but it worked.
If Chuck can do it, so can you.
That's right. I almost said that, but I didn't say that. No, I say that first, Jim. Don't worry about it. If it's anything to do with computers and stuff like that, I didn't grow up with them. But I'd also maybe I'll let this out, but
we're at the same age. I mean, I'm just like maybe a couple years younger than you there, Pop.
But I only have a high school education.
I look better. That's all I got, son.
It's all relative.
I went to college. I never stayed.
I went to
especially in Alabama.
In the fire service, I had to go. I thought I was out of school once I got a career. That's all we did was go to school. But anyhow, I'm also working on our newest antenna that we're going to offer from Coffee and Ham Radios. I won't say much about it, but that may debut somewhere around Memorial Day. So you guys might want to check that out.
Awesome.
It's a pretty cool antenna.
To keep on.
Next on. And tell you the truth, guys, we're not building these we build these antennas, kits and stuff, not to make money on it, but more we want hams to actually build their own stuff and learn how to build stuff. And that's what we're doing. And we use the money that we make just a little bit of profit on it, and we just put it towards the next project. So it's not like I'm not going to get rich off of this, believe me.
Well, the thing is that it's fun, right? And so it's fun for us to say, hey, let's try to design this antenna.
F word again.
And then we sit there and we argue with each other for about an hour and a half around, no, do it this way.
A day.
And then once we do that, then we have to figure out how we're going to get the parts, and we have to get it's exciting. And then my favorite thing about the last antenna that we did, the Artemis, is seeing the build pictures and the build videos that people are putting out.
That's right.
That y'all are doing. That's right.
It's like, hey, you know what? Like, this is awesome. And like, so I watched Shane's video, the side of the radio, and at the beginning he's like, well, golly shucks, doing his thing, and I'm going to put this together. And at the end of it, he had what looked like an antenna. Yeah, he had an antenna that looked like he bought it from a vendor at the end of the video, and I'm like, you know what? That is effing cool. That he was able to do that, and to me, that's the coolest part of it for me.
I did not expect that. He did have an outstanding looking finished product, and I don't know if he got help from somebody. I don't know, but it looked really good.
He did it on camera. It's got to be true.
Well, that takes some courage
on
to
the
do
internet.
it on camera like that and show it.
I could not do mine. I was going to try and do mine on camera, but all it would be was a series of beeps and cuts. And,
you should have.
And HOA Ham did a very good job on his as well, and posted a bunch of videos on it.
I'll tell you what, HOA, that guy. I want to take a class from that guy how to do videos.
Well, we're gonna have to. He had 3 cameras going at one point.
I know.
And we're gonna have to hire him to do our video instructional builds.
We need him to do our production. That's right. That's right. Yeah, and if you guys have a video, post it on at least in the Discord and share it with us of your.
We'll add it to the playlist. We got a playlist.
Yeah. You can be a famous YouTube celebrity as
Back
well.
on those 3 cameras. If you've never done a video, and if you've never done a video with multiple cameras, that is a ton of work to edit that, because now you gotta layer them all on there and pick out which angle you want. And it's like, man, most of the time I'm like, why did I do this when I do that?
Yeah. So what you don't know is that Bob bought 3 kits from us, and he had to do those 3 things in series, one after the other, and then splice all that together. And he couldn't make a mistake after the first one, or if he did make a mistake on the first one, he had to make that same exact mistake 2 more times. So
it was like a cooking show. Now I've got my raw souffle, and I'm going to take this cooked one out of the oven and show you what it looks like.
Right, exactly.
Yeah.
That's exactly.
Yeah, right. I think we also have coming up at the end of the month over Memorial Day weekend is the YouTubers Hamfest.
it is.
Yeah, we better start figuring out what we're going to do for that.
Right, which we will be participating in with glorious purpose, and bring you some awesome stuff over that weekend for sure. And there's a bunch of hams that are participating in that, so that ought to be pretty cool.
There's got to be at least 10 or 15, right? I mean, I didn't.
Well, it's pretty much constant videos from Friday afternoon all the way through Sunday morning.
Now we have some live streams in there as well.
It's live streams also.
Mm-hmm.
Yeah.
Yeah, there's some live streams, and then I guess a lot of premieres for the non live streams.
Yeah.
So Ape and I will build an oscilloscope live on camera, or we'll add 440 volt power to my house live on camera while we're drunk.
Right.
Actually,
both of those things seem totally legitimate.
What the heck are you doing, Ape?
I was wondering that.
I'm putting the lid back on my box.
Oh, okay. I saw a lot of hand movement. And a
I
big
know why
smile
that
on your
doesn't.
face.
You need labels on that, son. It don't look professional until you get.
I know.
some labels
Closing
on
up his
it.
box.
I had a P-Touch label maker, but the
I've had
kids.
2 cups of coffee. I need to pee.
Yeah, I do too. So we got to start wrapping this thing up. I've been drinking Mountain Dew like it's going out of style.
Andy said
Mountain
we
Dew
might
doesn't have
see
to.
him.
Mountain Dew doesn't have to stop to change color. You know what I mean? So it goes
slow
through.
down.
Right, it goes through fast.
Yeah,
Oh, Lord.
put an ape sticker on it. That would probably drop that.
That's
It'd
right.
probably correct.
Probably make those
frequency
correct that whole thing, and it's like, how did you build that cliff, Ape? I put an ape sticker on it.
All right, guys, we're going to get out of here. Y'all have a great weekend, the rest of your weekend, and ham on, and we will see you soon.
Glad you guys could join us.
Yep. Thank you, everybody.
See you, everybody.
Thanks
Hit
again.
that like. Hit that like.